Hi everybody. In this segment we will talk again about a contract that is aimed at coordinating the channel, at creating a win-win situation between the supplier and the retailer. This is the revenue sharing contract. So remember, the supplier still needs to get the retailer to order more, but now it uses a different scheme. Instead of using a buyback price, the supplier lowers the wholesale price, sometimes even below its cost, but it takes a percentage, 1 minus P of the revenue. By convention, we designate the percentage that the retailer gets by P and the percentage that the supplier gets 1 minus P. The question is how to choose these two parameters, W and P, so that the retailer will order the optimal amount. Before we get into it, let's talk about a specific case study where we happen to know what was happening between the retailer and the supplier. The supplier in this case was Paramount, which is a studio that makes movies and video, and the retailer was Blockbuster. This happened some time ago, before Netflix, before streaming video, before CDs. We are talking about VHS tapes. So the problem with VHS tape, the problem with this model is that the Blockbuster was buying the tape and then renting them for a certain price for usually 24 or 48 hours. And the issue is, at the first week that the tape would come, the demand would be very high and it wouldn't have enough. And then a week or two later, new movies will come out and the demand for the old movie will peter out and there would be too many tapes off the shelf of Blockbuster. So it was never, it never ordered enough for the beginning and it ordered too much for later. So let's see what was the situation before and what was the situation after. So in traditional pricing, the supplier said, I'll sell it for $600, for $60 per tape, and the retailer will buy at $60. At that point, they'll buy, let's say, 10 tapes, which means that the sales revenue for the supplier would be $600. And the purchase cost for the retailer would be the same $600. The issue is, we can look at the number of rentals, all assumption here, and the retailer profit, which in this case was $300, and the supplier profit, which in this case was $500. That's not the issue. The issue is that at the price of $60 per tape and at $3 per revenue, the retailer needed 60 divided by 3 equal 20 rental just to cover its cost. So it didn't owe too much because it needed 20 rentals just to cover its cost. So it wanted to rent every movie over and over again. So the supplier suggested a different model. Suggested a revenue sharing contract. The supplier said, I will sell each tape for only $9 a tape. Actually, even below its cost. But I will take 50% of the revenue of each tape. So now the situation was different. Now the retailer would buy for $9, but it can get only $1.50 per rental because it had to give $1.50 back to the supplier for each rental. The important thing is that the risk for the retailer was a lot lower because it needed only 9 divided by 1.5 equal 6 rental to cover its cost, not 20 rentals like before. So its risk was significantly lower. So in this case, it ordered a lot more tapes. The result, and you can go to the calculations, was that everybody was making more money. The retailer profit went from $300 to $480. The supplier profit went from $500 to $720. So in both cases, both sides made more money. It just so happened that this was a very successful scheme that actually went to court because the supplier offered it only to the large retailer, and so several of the small retailers sued them. But the supplier said that since they have to count on getting half the revenue, they have to make sure that the retailer is using a large accounting firm and using an ERP, and it cannot deal with a small retailer unless they use a large accounting firm and an ERP. And because, by the way, the Paramount won the suit, was thrown out of court, but because it went to court in the United States, it became public knowledge of what the deal was between the retailer and the supplier. So let's now talk about revenue sharing, and let's just put here the following parameters. We go to the same example that we are running throughout, and now we reduce the wholesale price from 50 to 40, but the supplier wants to take 60% of the profit and the retailer will take 40% of the profit. The rest of the parameters are the same. So let's now look at the spreadsheet and look what happens when we order 800 and the demand is only 600. In this case, out of the 600 that were sold at $200, the retailer is keeping only 0.4 of the revenue. But it pays less. It pays only $40 per tape. So for the $200 that were not sold, it still can salvage them for $10, but it paid only $40. So the total profit for the retailer is $18,000. If, on the other hand, the demand is 600 and 800 were bought, so for the 800 were bought for the original sales, the supplier is losing $10 on each sale. But on the 600 that were actually sold by the retailer, he is making 60% of the $200. So in total, he is making $64,000. Let's now look at what happens when 800 items were ordered and only 1,000 were demanded. So in this case, it's 800 times 200 times 0.4, that's what the retailer keeps, minus his cost, which is 800 times 40 is 32,000. For the supplier in this case, even though it loses $10 on the 800 that were ordered for him and then sold, he's making 60% on the sale of the retailer for a total profit of 88,000. So let's now look at the graph of the revenue sharing. This is the retailer, this is the supplier, and this is the total channel. And in this case, we see that we were able to move to 800, from 700 to 800. Moving the supplier is now participates in the risks. The channel remained the same. The channel is at 900. So let's see now how we get the optimal revenue share. And in this case, the optimal order of the retailer is P, which is the percentage that he keep out of the revenue, times R. This is now his new revenue, minus W, divided by, again, this revenue, which is in this case is P minus R, minus the salvage value. And we have to make sure that the optimal order for the retailer and the optimal order for the channel are the same. And we see that the critical ratio for both have to be the same, which is again giving us an equation of a line. So it's a relationship between P and W, and anywhere in this relationship, no matter what P and W are, as long as this relationship between them hold, we will have the optimal value, which means the retailer will order the amount that will maximize the expected profit for the channel, and there's a possibility for both retailer and supplier to make more money, to make higher profit. In this case, this is the line, and at $40, if the wholesale price is 40, the retail revenue share will have to be 76, and the supplier will keep, in this case, 24% of the profit. Of course, there can be also other value, just like before, but in this example of $40 wholesale price, the retail share of the revenue will be high, will be 76%. And if we look at the graphs in this case, at the retailer, at the supplier, and the total channel, they'll all be centered on 900. We can then do the same thing with normal approximation, and we will get 936 as expected. All the graphs, or the maximum of all the graphs, will totally align around 936. However, as I mentioned before, W equal 40 and P equal 0.76 are not the only values that coordinate the channel. If we look at the line that is defined by the relationship between W and P, we see that at 40 we will get 76. But for example, if we say that wholesale price is 25, then the retailer will keep only 40%. And it stands to reason. If the wholesale price is lower, then the supplier will want to keep a higher share of the profit. So at 40, the supplier will keep only 24%. The retailer keep, or 26%. The retailer will keep the rest. In this case, it's 76% for the retailer, 24% for the supplier. If we said the wholesale price will be 25, then the supplier will take 60% and the retailer will keep only 40%. In all of these cases, there's the incentive for the retailer to order the optimal amount so the channel will coordinate. Let's stop here, and we will go shortly into the next segment.